Well, you kind of had a chance to look around a little bit at the studio here. You can go ahead and start. And you know, when I was young, I was at the art museum and I was throwing pots. And I thought, how can I go higher? How can I go higher? And I took a piece of paper and I lit it, and all of a sudden it got hot and I could go a little bit higher. And then they called the director and they said the kids, you know, lighting fires in the art museum. And you know, but that's how you learn. You kind of you look and you have some adversity and you try to get through it. And this particular thing on K-Man, I talked to an engineer. He's like, man, there's no way you can do a 23-foot robot or structure. You're going to really have to work on the gears. So he gave me the gear ratios, and I went with these big 3-foot gears by 1-foot gears, made myself. And then I was working on it. The engineer called me and goes, Russ, it's not going to work. The legs are going to weigh 270 pounds. Even with that gear ratio, it's going to take 70 pounds of downward force, and so a kid would just be lifted, you know, right off the floor. And so then I thought about my mom's. I went to sleep and I started thinking about my mom's metronome for some reason. And you can see there that was the key. I put all the weight in the top, and that's my little nephew. My nephew, he's 2 years, 2 months there, and you can tell he's working it. So, and Stephanie gave me a great idea. I've got actually a whole other idea coming off of this that I think is going to be really great. But the structure and how you build things is really key. And here, this is, you can see how large it is. Actually, this is another one where the adversity of the engineer saying it's going to collapse led us to actually building a huge structure up the middle and building a fishbone-like interior structure that was all plug welded all the way through it. And so a number of other sculptors have kind of adopted that since then. And then this one has fused to the tip of it 100 times harder than stainless steel to make my own type of point bearing. So the fused stainless steel then will basically not wear out. And of course then it's aerodynamic, and then also it has an interior tension support system. If you look around, you've seen some of the neon stuff. Actually that's my, with these kind of, you know, it lights up as you're walking by. It's an electronic thing. But it's a whole other zone of kind of invention and passion for me. And basically what's different about this than anything else you'll see is I've made these clusters and I've stood them off 1 inch from the ground. So that's what's allowed me to build these clusters inside. There's no other, I mean, I don't actually know where I got the idea except for I wanted to build clusters in neon, and you can see my standoffs, and then the little electronics go from 1/3 volt to 1/2 volt to 110 all the way up to 9,000 to light the neon. So I was kind of a weird kid, and you can I built a little radio when I was 5 and ran the wire out the window and knocked my brother off the lawnmower with the wire. And I built my own computer when I was about 15 and got into really these 8088 processors. And this is the first real thing that we invented, which was a little device that took analog to digital input. There's a little chip buried in that thing, and I wrote a little C program, and the C program would basically, it was called Animouse, and it would animate the mouse from the digital to the other side, almost like what that lightning adapter is doing. In some ways, it's a reprogrammed port. And so that was adopted by the Language Research Center, and this is Kanzi, who's going through a maze program. And that little thing is actually what's enabling him to be able to control. It's animating the mouse. So from that, I got into this kind of black box, weird stuff. And so this was one of my first black box projects. And Public Sphere, sub-company of mine that I'd run for quite a while, and we kind of merged that into RuBert Studios at this point. But what's inside of a black box? I'm going to show you. You're about to see it. And it's really, really, really messy. It's really kind of ugly, because that's a little breadboard, and that's just me trying to figure out how to make this thing work. And basically, it's a relay thing. It's also doing the Animouse thing. It's doing video port stuff. And then I had a young kid out of Osceola come work for me, and he's gone on to develop this into a business now that's the largest in the country, really, for doing controlled devices. This is Kanzi. Kanzi's probably the genius chimp, the smartest chimp in the world. He's really actually a bonobo, and he has a language of just thousands of words. He's an amazing, amazing animal. And I worked with Kanzi for many years, from about 1981 through, well, actually even before that. But what I would do when I'd go there, at first I was cleaning the shit off the floors. And I realized I could weld and do machining and stuff like that, so this was like the first keyboards back in before you had to machine them, and then, so you can see these are like plastic Lexan pieces, and so that would make a flat panel. And I would assemble these panels basically for big mainframe computers. Now, this is before DOS, because we really didn't have the little computers that could do it like they do now. And so the brainstorm in one way was to create a new whole flat panel. So we created this first flat panel display, and then you could lay your Lexan on top of that and press it, and so that really solved a lot of the problems. But the real thing was how to really solve the problem. And we had as Steve Jobs came in, and there was 4 computers. He gave us 4 next computers because Apple had fired him. Scully came and helped us with some of those things. And what we were doing, though, was I took the board off, the whole thing, and then put a new screen on it and made the first touch screen. And this has been about more than 20 years ago now. And so that was my touch screen. And then this was the actual language system. And the language system was a number of interlayered screens. And basically, what I was surprised at was when Windows 8 came out the other day, and it's like, wait, that looks like our old screen from 20 years ago. And sure enough, they're doing some of the same things, because really all they're doing is they're bringing it back to a flat interface. And, you know, it's like this little flat phone, which is so amazing now. And let's just keep going. And he's going, can I see it? Can I see your phone now? Can I have your phone now? No. Can I have your phone? Can I see your phone now? No. I want to see your phone now? No. So it's really been a kind of an amazing evolution. As you can see, as you look around the studio here, I'm always kind of inventing. It's part of what I do.